Initial value theorem. Initial value theorem relates initial value of f of t at t equals to 0 plus to the limiting value of s into f of s as s approaches infinity. F of t function in time domain at t equals to 0 plus means time just after t equals to 0, means this value 0 just somewhere here, f of t and time axis just after 0, this. And this initial value theorem states that limit t tends to 0 plus f of t equals to limit s tends to infinity s into fs, means function f of t in time domain just after t equals to 0 is equal to function s into f of s where s tends to infinity. This is the time domain, this is the frequency domain. Where f of s is the Laplace transform of f of t. Some restrictions in the time domain, f of t must be continuous. F of t must be continuous. Continuous means any function like this. This is, we may consider at t equals to 4, let us consider. Then f of t limit t tends to 4 plus should be equal to limit t tends to 4 minus f of t. Just before 4 and just after 4 function value must be equal. This is the continuous function, and this restriction is followed everywhere. The two function be continuous. F of t may have at most one step discontinuity at t equals to 0. F of t may have at most one step discontinuity at t equals to 0. Step discontinuity means the function before t equals to 0 is continuous, function after t equals to 0 is continuous, and at t equals to 0 the function value has suddenly changed by some amount, that is d. This is known as step discontinuity. Now, restriction in frequency domain. What is the restriction in frequency domain? F of s must be a proper function. What is a proper function? The degree of the denominator polynomial of f of s must be greater than the degree of numerator polynomial of f of s. Degree of denominator, that is s square plus 3s plus 4, must be greater than the degree of numerator, that is s plus 7. Where f of s, this is the Laplace transform of f of t, and this is the transfer function. Degree of denominator must be greater than the degree of numerator. These two conditions must be followed for the application of initial value theorem. Now, an example, f of s equals to 2 into s plus 1 by s square plus 2s plus 5. This is given in the frequency domain, and find the f of 0 plus function value just after 0 in the time domain. This is to be calculated. Now, according to initial value theorem, first we check the restriction, that is the denominator polynomial have degree 2, numerator polynomial has degree 1. Hence, this statement is followed. F of t is a proper function. Hence initial value theorem are applied. According to initial value theorem, now limit s tends to infinity s into fs. If we calculate this term, then we get this value, f of t at t equals to 0 plus, that is required. If we calculate this, we can get the value because both are equal. Now, function is multiplied with s, limit s tends to infinity, the function 2 into s plus 1 by s square plus 2s plus 5 is multiplied with s equals to limit s tends to infinity 2s square plus 2s by s square plus 2s plus 5. Now, we divide the maximum power of either numerator or denominator, that is s square. On dividing by s square in numerator, in denominator we have limit s tends to infinity 2 s square by s square means 2 plus 2s by s square means 2s by s square means 2 by s square by s square, that is 1, 2s by s square by 2 by s, plus 5 by s square, that is 5 by s square, equals to, and put the value s equals to infinity. This term will 0, this term will 0, and this term will be 0, means that will be 2 by 1, that is 2, and this 2, this is the value of function in time domain at t equals to 0 plus, means at t just after t equals to 0, somewhere else here, f of t and t just after 0. Thank you.